Do you know why the moon Titan is preferred by scientists for potential colonization over Mars? So far, many scientists have considered the moon or Mars as the best places to take the first step in colonizing our solar system. These celestial bodies have the advantage of being relatively close to Earth and offering environments that our current technology can handle. Among the options, Mercury was discarded for being too close to the Sun, resulting in extremely high temperatures and harsh conditions. As for Venus, despite being even closer, it has a toxic and dense atmosphere. Furthermore, its uncontrolled greenhouse effect makes it an extremely hot place. Despite the Moon and Mars seeming like reasonable choices, both have fundamental issues. They lack a magnetic field and an atmosphere that can shield humans from dangerous cosmic radiation. This means that, in a migration scenario, we would have to live in underground shelters. Would you like to spend your life in an underground tunnel? That really doesn't seem like a solution. As a result, some planetary scientists have begun to argue that neither the Moon nor the Red Planet are ideal places to establish the first human colony. However, everything changes when we consider Saturn's largest moon, Titan. The surface of Titan has a temperature around -180 degrees Celsius and is covered by methane and ethane rains, forming hydrocarbon seas. Although this idea may seem surprising, scientists are confident that this is the only place where humans could establish a self-sustaining colony in the long term. But how would that be possible? Don't worry, we'll discover that at the end of this video. First, let's take a look at some basic information. Titan, one of the most mysterious moons in our solar system, is the second largest moon of Saturn. This moon has a dense atmosphere and unique geological features that have increasingly caught the attention of astronomers and astrobiologists over the years. Unlike other moons, Titan has different seasons and weather conditions, which can include cloudy, windy, or rainy days. Thus, we can say that it has a climate model quite similar to that of Earth. Titan has sand dunes, rivers, deltas, lakes, and seas on its surface. However, as mentioned earlier, the average temperature is around -180 degrees Celsius. Another major challenge is transportation issues on Titan. The surface is covered by methane and ethane rains and has extremely low temperatures. This requires special equipment and materials to land and operate on the surface. The challenges of reaching Titan include its vast distance from Earth, approximately 1 billion kilometers, which makes it difficult to reach with traditional chemical propulsion systems. Therefore, we need more efficient propulsion technologies and spacecraft designs to reach Titan. In recent years, ion engines and other advanced propulsion technologies have shown promise for long-range missions like this. Furthermore, once we arrive at Titan, the challenges of operating on the surface must be considered. The surface is covered by hydrocarbon lakes and has extremely low temperatures. This requires specific equipment and materials, such as cold-resistant spacesuits and protection against the effects of hydrocarbon lakes on the surface. However, when considering the potential for future colonization, let's examine the positive aspects of this environment. Titan's atmosphere shields the surface from cosmic radiation, meaning that a colony wouldn't need to be located below the surface. Additionally, Titan has the most nitrogen-rich atmosphere in the solar system, which means that humans could use the available nitrogen as a buffer to create breathable air by adding only oxygen. In fact, Titan's atmosphere has about 198 times more nitrogen than Earth's, compared to about 78% on Earth. This shows that, compared to other celestial bodies in the solar system, Titan is quite similar to Earth. It's important to note the lack of oxygen on Titan's surface. The glaciers beneath the surface could be easily tapped for oxygen, which is crucial for breathing and burning hydrocarbons. These glaciers would serve as ideal locations for future human colonization installations. In fact, scientists believe that most of Titan's crust is primarily composed of water ice. This means that Titan has all the hydrocarbon fuel sources that a human colony could need, and then some. In fact, there's hundreds of times more natural gas here than in all the known reserves on Earth. Additionally, even though it's not readily apparent, there's plenty of water here. The water on Titan's surface is about twice as cold as the coldest ever recorded on Earth. Therefore, it's permanently frozen and as hard as granite. Even without an internal salty ocean, there's still plenty of frozen water on the moon's surface. As mentioned before, this water is completely locked beneath the rocks below. In fact, scientists believe that Titan's outer crust is primarily composed of water ice, and extracting this source would be relatively easy. This means that Titan's seas could provide resources for construction. So, with an almost infinite source of liquid and solid hydrocarbons, Titan's settlers would have everything they need to build a permanent shelter on this celestial body. Instead of relying on wood, bricks, and metal like on Earth, using space polymers to build sustainable structures on the surface could be an ideal choice. Additionally, thanks to Saturn's thick atmosphere and magnetic field, surface hazards can be avoided. Instead of building underground shelters to shield from radiation, we can build habitats on the surface. Another fundamental challenge is energy. Due to its distance from the Sun and its dense atmosphere, the use of solar panels on Titan would be ineffective. The satellite's atmosphere is about 10 times thicker than Earth's. Therefore, the use of advanced nuclear reactors to generate power or the investigation of local resources such as methane and ethane lakes for energy production could be considered. Additionally, the use of alternative energies like wind or hydrogen could also be an option. On the other hand, there is so much nitrogen in Titan's atmosphere that we could use it as fertilizer, just like we do on Earth. Titan may seem like a daunting place at first glance, but it has all the elements necessary to establish a sustainable colony. However, the distance from Earth is a crucial factor. Preparing a solid infrastructure before sending humans is essential. Additionally, food production is a significant challenge in these conditions. Colonists will need to develop greenhouse cultivation systems capable of operating in Titan's cold conditions, using methane as a source of carbon for the plants. Cultivating resilient microorganisms that can convert local resources into food will be crucial to ensuring a sustainable food supply. Fortunately, Titan provides all the necessary fertilizer thanks to its nitrogen-rich atmosphere. In combination with abundant methane and ammonia, crops can be grown in a self-sustaining ecosystem. Saturn, with its 82 moons and rings composed of millions of ice particles, offers vast discovery potential. For example, Enceladus, nearby, has a liquid subsurface ocean, making it one of the most likely places for extraterrestrial life in the solar system. So, a permanent colony on Titan could serve as a launching point for journeys to other celestial bodies in the solar system. Furthermore, access to Titan would be relatively easy due to its small size and low gravity. This would significantly reduce the need for an extensive wingspan to sustain aircraft flight. In fact, an individual wearing a kind of winged suit easily manufacturable by current technology could fly on Titan. Regarding financial challenges, while a mission to Titan may seem costly, it is a necessary undertaking for future exploration. While reaching Mars may be cheaper, colonizing Titan is a long-term prospect. It requires a spacecraft specially designed to transport resources and sustain human life for extended periods. The crew needs to be carefully selected and trained to face the unique challenges of Titan. Before sending humans, it would be prudent to conduct advanced robotic missions to prepare the infrastructure. These robots would be responsible for building shelters, collecting resources, and preparing the environment for the arrival of the human crew. However, all of this requires a significant investment of financial resources. Additionally, current propulsion technology needs to evolve to make long-duration interplanetary travel viable. This could take decades, perhaps even centuries. The colonization of Titan will only become a reality when we achieve significant advances in this regard. However, there are no guarantees that this will happen. What do you think about this perspective? Share your thoughts in the comments. For more content like this, click on the video appearing on your screen.